Hello everyone, in this video we're going to talk about the different units of angle measurement. So let's get started. Alright, so here we go. So there are really two different types of units of angle measurement. The first one is going to be degrees, which probably many of you are familiar with. And the second one, let's use a different color for this one. The second one is going to be radians. Radians. Okay, and I'm gonna kind of talk a little bit about both of these, and I'm gonna make, I guess, a case for each. Okay, so first of all, what are degrees? Well, basically, it's an arbitrary number where we chose that there are 360 degrees in a circle. So let's go ahead real quickly, and let's just go ahead and draw one of these circles. Looks good. And if I went ahead from the middle or the center point of the circle and drew a line going out here, if I started right here, it would be at 0 degrees. And as I wrapped around, all the way around, okay, as I wrapped around, this would be 180 degrees. And if I kept on going all the way around, I would end up back here at 0, which would be the same as 360 degrees. Okay? So the real question here is why? I told you this is an arbitrary number. We could have chosen 10 degrees in the circle. We could have chosen, 100, 1,000, 500, 721, whatever, right? It could have been anything, literally anything. So why? And so this was decided a long time ago, right? These are ancient civilizations, right? These are like the Babylonians, the Sumerians, the Greeks, right? These very ancient civilizations. So what would be I guess what were they thinking, right? What was going through some of their minds in for them to choose this, right? Civilizations, ancient civilizations. Okay. And I'm gonna kind of offer two probable explanations. I'm not gonna say this is 100% sure because we really don't know 100% for sure, but we can definitely just kind of reflect and think about what they may have been thinking. Well, number one is if you look back at the calendars back then, most calendars were around 360 days. Okay. Yeah, our calendars were not always 365 days. In fact, there actually aren't exactly 365 days in the year. It's actually 365.25 something like that, right? Some number that goes on forever or whatever. So yeah, so what we use today is really not even exact, but so back then, they definitely weren't exact, and so the calendars typically use 360 days or around there, and so that could be a reason. Not really sure. Could be a reason. And I'm going to offer one more explanation that I think is a little bit more logical. Both of these could be true. Neither of them could be true. But basically, 360 is a highly composite number. Is highly composite. Composite. So, what does it mean to be highly composite? All right, I'm just going to put some notes down here real quick. So, for example, we use what's called the decimal system, deci meaning 10. 10 is actually not a highly composite number. So, 10, when you break down its factors, there are 1, 2, 5, and 10. Okay. If I broke down the factors of like 7, for example, right? Definitely not highly composite. That's just 1 and 7. Okay. But if I go up just a little bit higher, if I go to 12, 12 is actually a highly composite number because it has a lot of factors for where it's at on the number line. Okay, so if I wrote out the factors for 12, it's 1, 2, 3, 4, 6, and 12. Yeah, that's quite a few factors actually because there are only 12 numbers, right, between 1 and 12, and 6 of them, half of them are factors, right? That's kind of crazy, actually. And so as we get higher and higher up the number line, 360 is highly composite, right? It's got all of these, 1, 2, 3, 4, 6, 12, and then just tons and tons more, all right, going all the way up to 360. So it's very highly composite. So the next question might be, why is it beneficial to be highly composite, right? They chose 360 probably because it was highly composite. Why? Well, the answer is probably because they didn't have calculators or anything like that back then, right? It made sense to choose a number that could be broken down into nice whole numbers, right? And a highly composite number can do that. Okay. And furthermore, let me erase all this so that way I have room later on. But furthermore, I just want to show you something very quickly before we move on to radians. But if let me grab my brush back here. Oops, sorry. Moving all over the place. All right. But if I went ahead and divided this circumference into 6, approximately, something like that. Let's see, about there, and about there. And I went from the center out to each one of these points. And actually, I should probably use a line. Let me do that. Let's just see what happens here. This is just kind of a demonstration to how nicely things work out when you use 360. Connect all the dots here. And so what you might notice is that now I have kind of estimated this circle. There's a little bit of room in between here, but basically I have 6 equilateral triangles, which is really nice because you might recall with an equilateral triangle, all the angles are the same. They're actually all 60 degrees, which is a factor of 360, by the way. And all of the side lengths are the same as well. So just kind of some interesting properties there. Okay. Okay, so let's move on to radians. All right, and so students really like degrees mostly because they're used to working with them. They've used them for a long, long time. But radians actually probably make more sense to use, just so you are aware, instead of degrees. And so this might be the first time you've ever seen a radian. Let's talk about what it is, right? It's another way to measure the angles, right, of a within a circle, but basically it relates. Let's say it relates the angle or circumference. Let's say the angle. We'll call it the angle, like this little angle symbol. Relates angle to the radius, which is actually pretty interesting because basically we can describe any circle with just its radius, and then we can figure out quite a bit more based on just that radius. Okay, so let's go ahead and figure out, or demonstrate what this means. Okay, so let's go ahead and draw another one of these big circles here, and I will go ahead and put in another little line, horizontal line from the center over to the right. Okay. All right. So let's call this R for radius, right? This is one radius. And if I took like a string, for example, that was the exact same length of this radius, and I started right here, I called this 0R. Okay. I'm at 0 radians. Radians is for radius, right? And I started wrapping it around this circle. Let's say I got approximately right here. And so at this, if I wrapped it around the circle, right on the circle, okay, let's call this 1R or 1 radian, right? Or 1 radius, right? And let's wrap it around again. And maybe we get to like, I don't know, let's say right here. Kind of guesstimating here. Let's say that's 2 radians. And I wrapped it around again. I would probably get to approximately like right here. Let's say 3 radians. So that's 3 lengths of the radius. Okay, and actually, you might be interested to know that that is actually just short of the horizontal line going straight across. And we'll talk about that distance in a second. But let's keep wrapping this around. Right? Again, approximation. So 4R. Let's call this 5R. And let's call this 6r. And again, this is just short of getting back. Okay, so let's go ahead and grab another color here so to demonstrate this. So the next question is, well, what is this distance? And also, what is this distance here? And so you might be surprised to find out that that distance is actually, this little distance is equivalent to approximately 0.14159 dot 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 repeating. It actually repeats forever. And so you might notice that if you combine these two, 3 radians and the little bit that we're missing, if I added those, you'd end up with 3.14159 dot 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 going on forever, which is equivalent, not almost equivalent, right? This is equivalent to pi. Very interesting. So, 180 degrees, if I went from 0 halfway around a circle, 180 degrees is halfway around. If I go, I could say the same thing in radians. I would go from 0 radians to, it's not 3r, but it's pi, right? So this thing goes from 0 to pi, all right? Now, if I keep wrapping it around, go this way, I would add another pi on there. So 1 pi gets half the circle, and 2 pi's gets you all the way back around. So 0 radians or 0 pi is the same thing as 2 pi. And if I wrapped all the way around again, it would be 4 pi, and so on and so forth. Okay, so let's just write this on the side here. I'm going to say that 360 degrees, actually, let's do it this way. Let's say 180 degrees is equal to 1 pi, and 360 degrees is equal to 2 pi. Either way, we are measuring the same thing, right? These are just units of measurement for the angles inside of a circle. All right, there we go.